Hello everyone, this is Mr. McMillan, and this is an instructional video for the notes on the parallel and perpendicular lines and slopes. And in this video, I'm going to be working through all of the example problems that were present on the page step by step. So this should be mostly a look back through algebra because you learn this in algebra and in some parts of it in 8th grade as well, in 7th grade as well. And first thing is parallel lines. And two lines are said to be parallel lines if they lie on the same plane and never intersect. Okay? So two lines are parallel lines if they lie on the same plane and never intersect. This means that the lines never touch. They never touch. Okay? Now, since the lines never intersect, that means that the slopes have a specific property. And the slopes of parallel lines must be exactly the same. Okay? The same sign, same value. This means they are equal. So symbolically, the slope of the first line has to equal slope of the second line. So M1 must equal M2. Now, like most things in geometry, we use symbols to indicate when things are, have a specific property. And if two lines are parallel, the symbol that we use are two bars, vertical bars, straight up and down. And it looks like the number 11, but it's not. So, for example, if lines A and B are parallel, then we would write the first line, which is A, and then the symbol for parallel, and then B. So this will be read as A is parallel to B. So, to indicate parallel lines on graphs, there are two things that you may see being used. So the first one is we either use triangles, and the triangles literally just look like triangles that are colored in and they sit on the graph. Or you might see what are known as chevrons. And all chevrons are is a triangle or an arrowhead that's missing the body of the arrow. Okay. So these four diagrams below are examples of parallel lines. Okay. So in this first graph here, we have lines R and S. And if you look here, these two lines both have one single triangle on them. And since they have the same number of triangles, that means that they are parallel to one another. So R is parallel to S. Next up, you have lines D and C. Now, it does not matter how many triangles are on it. All that matters is that they have the same number. So here, D has two triangles, so does C, so that means these two are parallel. So D is parallel to C. Then our third situation here, we have L and K. And if you look here, they don't have triangles this time, but they do have the little chevron, right? So the little chevron indicates that they are parallel because they have the same number of them. So L is parallel to K. And then finally, we have a couple of equations here. And if you remember, the slopes of parallel lines must be the same. So they must have equal values. So remember, y equals mx plus b. The number in front of x is your slope. So m1 is 7 here, and m2 is also 7, which is that second line. So those check out, so they are parallel. All right, so let's talk about perpendicular lines. Now, two lines are perpendicular if they intersect to form 4 right angles. And a reminder that the degree measure for a right angle is 90 degrees. Okay. The slopes of perpendicular lines are negative reciprocals. Negative reciprocals. Now, this trips up everybody, but what this means is that the product of M1 and M2 is equal to -1. So that's why they're called negative reciprocals. If you remember about reciprocals, they were when you took a fraction and flipped it, and if you multiplied them together, you got 1. Okay? They were the multiplicative inverses. Negative reciprocals have to have opposite signs. So they're flipped fractions with opposite signs. So symbolically, the product of M1 and M2 being equal to -1 is written M sub 1 times M sub 2, which is equal to -1. So again, like I said, to find negative reciprocals, you take your original slope, you flip the fraction, and change the sign. So if you had, for example, your slope was 5, well, 5 becomes 5 over 1 on the fraction. You flip the fraction to become 1 over 5, then you change the sign. So your perpendicular slope to a slope of 5 is -1/5. We'll be doing quite a few examples of that here in a bit. All right, if two lines are perpendicular, we use the symbol, and the symbol looks like this. It looks like an upside down T to indicate this, okay? So, for example, if lines A and B are perpendicular, then we would write that A is perpendicular to B. A is perpendicular to B. All right. And just like parallel lines, we can look at a graph to determine if we have two perpendicular lines. And what we're going to be looking for is those right angle markings. Okay, so we're looking for right angle markings on a graph. And if you remember the right angle marking, it's a box in the corner. All right, so in the following diagrams here, there are two diagrams, one here on the left and or two here on the left, and then we have two pairs of equations on the right. So on the left here, we have a 90-degree angle here, and that's represented by this corner box here. So since we have a 90-degree angle, we know that M is perpendicular to N. All right. Similarly, if we look here at this second diagram, we see lines P and R. They intersect here, and they have a right angle marking there, a corner marking there. So that corner marking indicates that P is perpendicular to R. All right, next up, if we look at the two sets of lines here, remember that the product of the slopes of two lines must be equal to -1 for them to be perpendicular. So here, your first slope is -2, and you're going to multiply that by your second slope, which is 1/2, and that gives you -1. So these indeed are perpendicular because of that. Similarly, if you do the same thing here, 4/5 times -5/4. When you do that, you get -20 over 20, which is -1. Okay. So the product of their slopes must be equal to -1. They must be negative reciprocals to be perpendicular. Parallel's easy. Are they the same slope? Yes. Then they're parallel. If no, then they're not. So let's look at some example problems. So number 1, in the chart below, match each given linear equation with the equation that forms a parallel and perpendicular line with that equation. So we're going to do our parallel ones first, and then we'll do our perpendicular. On the left side here, I'm going to write out the slopes for each equation. So the slope here, this equation here, remember y equals mx plus b. So your slope has to equal the number in front of x, which in this case is 5. In the second set, it is -1/2. And in the third, it's -4. So if we're wanting to find the parallel line, we need to find the line that has the exact same slope. So for y equals 5x minus 8, if it has to have the same slope, that means that the equation that's from here needs to have a slope of 5 as well. So do you see any that have a slope of 5? Well, you should. You should see that it's y equals 5x. So that would be our parallel line. All right. So try the next two parallel lines. Pause the video, come back and check your answers. All right, so for the parallel line for y equals -1 over 2x plus 7, it has to have a slope of -2, or sorry, -1/2, excuse me. And that would be y equals -1/2 x minus 3. And then our parallel line for y equals -4x, y equals -4x would have to have a slope of -4. And the slope that has -4 here is y equals -4x plus 17. All right, so let's look at the perpendicular lines. Now, remember that the perpendicular lines, their products must be equal to -1. Now, you could do that, or you could just go ahead and find your perpendicular slopes and then check and see which one matches up. I'm going to do it that way. You can do it whichever way you like. So here, I've got m equals 5. So what you do is you take your original slope 5 over 1. You're going to flip this fraction, which makes it 1 over 5. And then you're going to change the sign. So the slope of your perpendicular line will be -1 over 5, which will be this first one here. Y equals -1 over 5x plus 2. Okay. See if you can determine the perpendicular lines for the second and the third one. Pause the video, try it, and then come back and see if you're right. So let's look at this one. We have -1/2 as our slope. So we're going to flip the fraction, which makes it -2/1. And then we're going to change that negative to a positive. And so that slope should be 2. So that means the perpendicular line to that one would be y equals 2x plus 5. And then finally, your perpendicular slope to -4/1 would be equal to 1/4. So that means your perpendicular line here would be y, sorry, that's not the right one. This one. Y equals 1/4 x minus 3/2. All right, so in these next ones, it wants you to determine whether the following pairs of lines and lines that are formed would be parallel, perpendicular, or neither, okay? So let's look at number 2. We have y equals 2x plus 1 and 4, 2 and 8, 4. So what we need to do here is determine the slope of both of these lines. So the first one's easy. It's already in slope-intercept form. So we take that 2, and that's our slope. So the first slope is m equals 2. Now we do our other slope. Okay, so we have 4, 2 and 8, 4. So we have to use our slope formula. So m equals y2 minus y1, so 4 minus 2, over x2 minus x1, so 8 minus 4. 4 minus 2 is 2. 8 minus 4 is 4. Simplifying that, we get 1/2. So now we ask ourselves, are these parallel? Well, if we look at these two slopes, they are clearly not the same, so they're not parallel. Are they perpendicular? If we take 2 and multiply it by 1/2, do we get -1/2? And the answer is no, we get 1. So it's not perpendicular. So that means that it must be neither. Okay, so let's look at number 3. Number 3 says y equals -1/5 x plus 2, and 3, -2, and 1, -10. So what we need to do here, find our slopes. So for this first line here, we have m equals -1/5. And for our second line here, we need to figure it out using our slope formula. So we have m equals y2 minus y1, so -10 minus -2, that becomes -10 plus 2, over x2 minus x1, which becomes 1 minus 3. Simplifying that, we get -10 plus 2 is -8. 1 minus 3 is -2, and that gives us 4. So are these parallel? 4 and -1/5 are not the same, so no, they are not. Are they perpendicular? Well, if you multiply -1/5 times 4, do you get -1? No, you get -4/5. So this is also neither. All right. So now we're going to look at number 4. Number 4, we have 2, 3, and -10, 6, and 7, 2, and 14, -10. So you need to determine the slope for each one of these sets of lines, or sets of points. So here you have, for your first slope, you have 6 minus 3 over -10 minus 2. And when you do that, you get 3 over -12. And if you simplify that, you get that m is equal to -1/4. Next up, you have 7, 2, and 14, -10. So your slope, m equals y2 minus y1, so -10 minus 2, over 14 minus 7. So this gives you negative 12 over 7, which cannot be simplified. Clearly, these are not parallel because they're not the same. They would have to be exactly the same. And if we multiply these two together, we're not going to get negative 1. And we're not going to get negative 1 because if we take a negative here and a negative here and multiply them together, that is just positive. So this would also be neither. Okay. All right, it looks like number 8 and number 9 are duplicates of these two up here, so that's unfortunate. So we're going to ignore those. Okay. So let's look at 5, and then I want you to try number 6 and 7 on your own. Okay. So we're going to do 5 and then look at 6 and 7 on your own. So that is my bad on numbers 8 and 9, but you know, you'll get the point. Pretty okay with this. All right. All right, so number 5 here. Number 5, you have 2, 3, and negative 5, 7. So we're going to find the slope of that one first. So the slope here, we have 7 minus 3 over negative 5 minus 2. And when we do that, we get 7 minus 3 is 4. Negative 5 minus 2 is negative 7. And then I'm just going to put the negative up top there because that's how I tend to do it. That's how it's tend to be written anyway. Then we have 4, 7, and 8, 14. So we have y2 minus y1, which would give us 14 minus 7. And then we have 8 minus 4. So 14 minus 7 is 7. 8 minus 4 is 4. So are these lines parallel? Well, they need to have the same slope. They do not have the same slope, so they are not parallel. Are they perpendicular? Well, if we take their slopes, negative 4 over 7, and multiply them together, 7 over 4, negative 4 times 7 gives you negative 28. And then here, 7 times 4 gives you 28. Negative 28 over 28 is negative 1. So these are perpendicular. I'm just going to write the symbol. So those are perpendicular. Okay. All right, so look at number 6 and 7, see if you can do those. So pause the video and then come back to them, to the video to check your answers. All right, so let's look at number 6. Y equals 7 to x minus 3. That has a slope of 7. And we need to find the slope of these other 2 points. So the slope is equal to y2 minus y1. So 3 minus negative 4, which becomes 3 plus 4, over. And then we have 5 minus 6 here. So 3 plus 4 is 7. 5 minus 6 is negative 1. So 7 over negative 1 gives you negative 7. Are these slopes the same? No, they are not. They have opposite signs. Are they negative reciprocals of one another so they could be perpendicular? Well, if you take 7 times negative 7, that gives you negative 49, which is nowhere near negative 1. So these are not perpendicular. So this is neither. And number 7, you have 3, 7, and 3, negative 8. So we have 3, 7, and 3, negative 8. So you have negative 8 minus 7 over 3 minus 3. If you simplify that, you get negative 15 over 0. You cannot divide by 0, so this is undefined. All right, let's look at the next one here. you have the slope 2 minus 5 over 2 minus 2. 2 minus 5 is negative 3. 2 minus 2 is 0. Again, cannot divide by 0. And so you get undefined as well. Are those slopes the same? They both came out to be undefined, so they are the same. So that means that this is parallel. Okay. All right, let's look at the next set of problems here. So the next set of problems, find the slope of a line that is parallel to the given line or the line that contains the given points. So we're looking for parallel slopes, which means that we're looking for the same slope. So whatever slope that you have is the slope that would be parallel. Okay. So number 10, your original slope for your equation is 7 over 3 because it's in front of the x. So that means that the parallel slope has to be equal to 7 over 3 as well. Number 11, you're given 2 points here. So you need to find your slope first. So you have y2 minus y1. So you have 5 plus 7 over. And then you have negative 2 minus negative 8, which becomes negative 2 plus 8. 5 plus 7 is 12. Negative 2 plus 8 is 6. So the slope is equal to 2. That would be what your parallel slope would have to be as well, because they have to be the same slope. Number 12 and 13, you're given a graph. So on number 12, you need to use rise over run, and you go up 2 for your rise, and to the right 2 for your run. So m equals rise over run. So m equals 2 over 2, which is equal to 1. And since this line has to be parallel, we know that our other slope for the parallel line must also equal 1. Now, number 13 can be solved in a couple of different ways. One, you can look at this and realize you're dealing with a vertical line, which always has a certain slope. What you can also do is you can still do your rise over your run. So if you start from this point and you go up, you have to go up 5 units. So that's a plus 5 rise. But what is your run? Are you running at all here? Are you going any degree left and right? And the answer is no. So your run, or your rise over your run, is 5 over 0. So your slope is undefined. So your parallel slope would also have to be undefined. Now, if you ran into a situation where you wanted to determine the perpendicular slope for an undefined line, that would be equal to 0, because then it would cross like this and make a right angle. All right, number 14. 14 through 17 wants us to find the slope of a line that is perpendicular. Okay, so this is where you're going to need to flip the fraction and then change the sign. So number 14, y equals negative 5x minus 17. Well, what is our original slope? Well, our original slope here is the number in front of x, which is negative 5. Now, since it's not a fraction, we're going to put it over 1. We need to flip the fraction. So that becomes 1 over 5, negative 1 over 5, and then we change the sign. So the negative becomes a positive. So our perpendicular slope would be equal to 1 over 5. The way you can check this, you can take the slope that you had originally and multiply it by the slope the slope that you found and see if it equals negative 1. And if you take 1/5 and multiply it by negative 5, you will get -1. Number 15. Number 15, we have to find our slope first. So we're going to use our slope formula. So -1 minus 6 over, and then we have -4 minus 12. -1 minus 6 is -7. -4 minus 12 is -16. So this gives us 7 over 16. But we're not done yet because we want to find the perpendicular slope. So we want to find the perpendicular slope. We flip the fraction. So we flip 7 over 16 to where it becomes 16 over 7. And then it's positive, so we have to change the sign to a negative. So our perpendicular slope for this one is -16 over 7. Number 16, we have the graph of a line, so we have to find our slope first by rise over run. So we're rising by 1, and we're running 1, 2, 3 across. So our slope is equal to the rise over the run, which is equal to 1 over 3. Now we take our original slope here, and since we're trying to find it perpendicular, we need to flip the fraction, which becomes 3 over 1, change the sign, and then simplify. -3 over 1 becomes -3. And then number 17, do the exact same thing, find your slope first. So we're going to start from the leftmost point. We're going to go down 1, 2, 3, 4, 5. So we're having a rise of -5 and then a run of +2. So our slope is rise over run, so -5 over 2. But we have to find the perpendicular slope. So we're going to flip the fraction and change the sign. So this becomes 2 over 5 negative, but then we change that to a positive, and so our perpendicular slope is 2 over 5. And again, you can always check these by multiplying the two slopes that you have together and seeing if you get -1. All right, and these last 4 that we're going to do, we're going to be graphing lines, and the reason that we didn't really cover this in class because there's no real good way to do that with the time that we had. So we're going to go through them right now. So we have y equals 3x plus 4, and we want a line that's parallel to the given line that passes through this point here. So we want one that passes through the point 1 over 2. So I'm going to go ahead and graph 1, 2. So that's my line. Now I want to graph a line that's parallel to that line. Okay, well, y equals 3x plus 4. The slope of our parallel line has to be the same. So the slope that we have to use is equal to 3. So we're going to start at this point. Now, since it's 3, we're going to go up 3. And then since it's positive, we're going to go to the right 1. So up 3 to the right 1. Well, we can't go any further there. So now we're going to go down 3, 1, 2, 3. And since it's positive, we have to go to the left to cancel out the negative. And then we're going to keep doing that. Down 3, left 1. And that's how you graph the line. If you remember graphing lines in algebra, you use your rise over the run. Now, if you were to graph the other line, you can see that they are indeed parallel. So you had plus 4, and then you would go here, and then here, and then here. And you can see, if I could draw better, but assume that those two are straight lines that are actually straight, and those two lines would never intersect. So let's look at number 19. You can try it if you'd like. We want the line that's parallel to the given line that passes through this point. So we're going to go ahead and plot that, -3, -2. Now the slope of this line is -1/5. And since we want a parallel line, that's the slope we have to use. So if we go up, we would need to go to the left. Well, I don't have enough space to go to the left from here, so I'm going to need to go down. And since it's negative, I need to go to the right. So I'm going to go down 1, to the right 5. So 1, 2, 3, 4, 5. And that's really the only space that I have, because otherwise I'm off the graph. So if you graph that to the best of your ability, and I don't have a lot of it, you get that line there. Okay? All right. The last two here, they're the same deal, just with perpendicular lines. So it wants us to graph a line that's perpendicular to the given line that passes through the point. So on number 20, it passes through 0, 1. And our slope for our original line is 2, but we need the perpendicular slope. So we take 2/1, flip the fraction, change the sign. So we get 1/2 and then a negative. So we're going to start here. If we go up, then we'll have to go left because it's negative. So up 1, to the left 2. Then we go up 1 more and to the left 2. Up 1 more, left 2. Start back at the beginning. Down 1, right 2. Down 1, right 2. Down 1, right 2. And then we draw or connect the dots. Everybody's favorite pastime as a child. And if we graph the other line here, and I just am going to do this real quick. And we were to measure that, we would see that these do indeed form a right angle there. Again, assuming I could draw a straight line. Okay? All right. And our last one here, number 21, y equals 2/3 x plus 8, passes through the point 2, -1. So it has to pass through 2, -1. And we want a perpendicular slope to this line. So our original slope is 2/3. We flip the fraction and change the sign, and we get 3/2. It was initially positive, so we make it negative. So we're going to start here. If we go down, we need to go to the right after that. So down 3, 1, 2, 3, to the right 2. There. Start back and we go up 3, 1, 2, 3, to the left 2. Up 3, to the left 2, so on and so forth. Okay. And again, if we were to graph the other line, which I can't really do because of the massive y-intercept, we would be able to see that they would cross at a 90-degree angle. And that does it for this video, guys. I hope this video helped, especially if you needed to come back and rewatch it just to refresh yourself. As always, if you do need help with any of the concepts, please email me and make sure that I know. We can schedule a Zoom time to go back over the material and, you know, help you understand it the best that you can. Okay. So thanks, guys, and I will see you in the next video.